In this video, we're going to be taking a look at chords and arcs. So before we get started, let's draw a circle and define what an arc is and what a chord is. Right now, you guys should already know what an arc and a chord, what an arc is. If this is A and this is B, the arc AB is this. And arcs are measured in degrees. So what is a chord? A chord is a line drawn between any 2 points on a circle. So if I draw this line, this green line is considered a chord. The longest chord of a circle goes through the center. The longest chord of a circle goes through the center, and it has a special name. It is the diameter of the circle. So a diameter is a chord because it connects 2 points on the outside of a circle, and it is the longest chord in the circle. So let's take a look at a couple of theorems and postulates that have to do with chords and arcs. So the first is within a circle or two congruent circles, congruent central angles give you congruent arcs. Okay. Also, if we read this backwards, within a circle or two congruent circles, congruent arcs give you congruent central angles. All right, so within a circle or two congruent circles, congruent central angles have congruent chords. Congruent chords have congruent central angles. Within a circle or two congruent circles, congruent chords have congruent arcs. Congruent arcs have congruent chords. And within a circle or two congruent circles, chords equidistant from the center are congruent. Congruent chords are equidistant from the center. So all four of these go both forwards and backwards. The next two, it says in a circle, if a diameter is perpendicular to a chord, then it bisects the chord. Also, if a chord is bisected, then what's bisecting it is the diameter of the circle. Okay? Oh, hold on. It says if a diameter is perpendicular to a chord, then it bisects the chord. If the chord is being bisected, then it's yes, how do you say that? Yeah, then it's being bisected by the diameter. All right, so if in a circle, the perpendicular bisector of a chord contains the center of the circle. Okay, so that means that chord, the perpendicular bisector of any chord, lies along the diameter of a circle. So let's work through some of these examples to illustrate what we were talking about with those postulates and theorems. So it says circle A and circle X are congruent. What can you infer? Well, we can use all of these postulates up here because it says within two congruent circles. So if we can find central angles that are congruent, then we can infer their arcs are congruent. So we have central angles, two central angles that are congruent right here, then their arcs are congruent. So that arc is arc BC must be congruent to arc YZ. So arc BC is congruent to arc YZ. What else does it say about this? It says if we have two central angles that are congruent, then the chords are congruent. Okay, we have two central angles, so what are the chords? BC is a chord that has this red central angle, and YZ is a chord that has the red central angle. So BC is congruent to YZ. Those are the things that we can infer. So does it have anything else? It says, well, if you had two congruent chords, then their arcs are congruent. Well, it didn't say the chords were congruent, so we can't necessarily say that, although we know the chords are congruent now. Doesn't talk about equidistant from the center. So that's about all we can infer from this. So because the central angles are congruent right here, these central angles are congruent, their arcs are congruent, arc BC and YZ, and their chords are congruent. Okay, so now in these problems we're going to find the value of x. And I think I forgot to write something down in this problem. Let's assume that x is, or not x, this part is 12.5. Yes, I thought I forgot to write something down. Okay, so we were told that in a circle, if two chords are equidistant from the center. So let's see what that says. In a circle, if chords are equidistant from the center, then those chords are congruent. So here I have this distance of 9, which is congruent to this distance of 9. So chord SR is equidistant from chord PR, so these two chords are congruent. So if I can figure out what PR is, I know what SR is. Well, PR is 12.5, and since these segments are equal, 12.5 and 12.5. So SR has to be 12.5 plus 12.5, right? SR and PR are congruent, and that equals 25. So SR has a measure of 25. All right, so how about X here? Well, we're told in the same theorem, right? If we read this theorem backwards, within a circle or two congruent circles, if we have congruent chords, then they are equidistant from the center. So do we have congruent chords? Let's see. This chord right here has a measure of 36, and this chord right here has a measure of 36. That means their distance from this center here, these two lengths must be equal. So X has to equal 16. 16, not 6. All right, so now let's take a look at this picture right here. We have a circle, we have two diameters, X, Y, and WZ are diameters, and we have two chords. We have YZ and WX are chords. So what does it say? It says arc, the measure of arc XZ, this measure right here, is 40 degrees. So that means angle 4 must be 40, because angle 1 and angle 4 are vertical angles. Angle 1 must be 40. So I know that all the angles in a circle, if I go around this circle, they must add to 360 degrees, but I also know that 2 and 3 are vertical angles, so they're congruent. So I know that 40 plus 40 plus, let's just call angle 2 and 3 X and X, X and X, that has to equal 360 degrees. So that's 80 degrees plus 2X equals 360. 2X equals 280. That means X is 140 degrees. Each one of these is 140 degrees. All right, so let's answer the questions here. The measure of angle 1, that's easy now, 40 degrees. The measure of angle 4, 40 degrees. The measure of angle 2 and 3, they're the same. Both of them are 140 degrees. The measure of angle WX, or not measure of angle WX, the arc WX has a measure of the same as its central angle, so 140 degrees. And then arc WY has the same measure as its central angle of 40 degrees. What do you know about the distance from O to WX and O to WY? Well, the distance, right? This distance, and when we calculate distance, it's always the perpendicular distance. That distance, since my chords have the same central angle, right? This central angle, this red angle right here, this angle and this angle are congruent because they are vertical angles. Because the central angles are congruent of these chords, the distance from the center to each chord is congruent. So the distance from the center to WX and YZ is equal, right? The measure of that distance is equal because the central angles are equal. Okay, so now it's asking us to find the value of X. So let's take a look at this. Oh, here's X right here. How would I solve this? Well, 30 actually is this whole distance, and 20 is this whole distance. But we were told that if we draw, right, a perpendicular line from the center to a chord, it splits it in half. So this to this is equal, right? I know that this is my diameter, so half of it is equal to the other half. So when I draw this separate triangle here, I get a triangle that looks like this. This is going to be 10 and this is going to be 15 because those distances are halved. So this is just Pythagorean's theorem, and this is my hypotenuse over here. So I have to set it up 10 squared plus x squared is my hypotenuse squared. So I get 100 plus x squared is 225. X squared is 115. And so x is going to be the square root of 115. So does that reduce? 115 is 5 times 23. So there's no perfect squares in 115. So x is the square root of 115. So how about this one? Again, I was told that if I draw a perpendicular line from the center of my circle to a chord, my chord gets split in half. So each half is 5. Okay, so it looks like I have to find the radius of the circle, so I can draw a radius anywhere I want, and because all radii are congruent, I can label that x. So this is going to be my hypotenuse. So with Pythagorean's theorem, 5 squared plus 3 squared equals x squared. 25 plus 9 equals x squared. 34 equals x squared. So x equals the square root of 34. 34, the only two factors are 2 and 14, so that does not reduce. Let's see if we can fit these two in. All right, so here I know that this, because this is perpendicular to my chord, it starts from the center of the circle and it's perpendicular to my chord, it splits my chord in half. So if I can find this, then I can find the entire length. So let's draw my triangle out. This is 9 and this is 15. And I don't want to call it x, let's just call it y, because x is the whole chord, not half of it. So I can say this is my hypotenuse, so 9 squared plus y squared equals 15 squared. 81 plus y squared equals 225. Y squared, let's see, that would be 144. So y equals 12. All right, so that's 12. So this is 12. That means that is 12. So x must be 24. Okay, so I'm going to continue the rest of my examples. There aren't many left on the next video.